Good morning, all. Are you all excited about this conference? Having fun? How many are having fun?
Oh, come on.
Come on.
Yeah.
I was thinking of catching the return flight if you don't. Okay. As Carl mentioned, we are still working on some of these pieces, so I have to show you this, which just means there's no commitment from Oracle to deliver anything that I'm going to say, which kind of gives me a lot of freedom to talk about anything under the world. So let's start talking about how IoT solutions are built today. Most of the solutions look like this, right? You have devices, and lots of devices, various types of devices, and they take a lot of data, they generate a lot of data and send it to your back-end data center or cloud or what have you, and then it becomes a big data problem where you can analyze that data, you can make decisions, and then you connect it with your back-end applications where you make actual final decisions on what should be done based on that data. That's how most of our today's services that are built in the world today look like. But if you just stay at this, I don't think we'll realize the full potential of IoT. To realize the full potential of IoT, we got to also do the reverse direction communication, which means first and foremost change is the sensor or the thing in the Internet of Things is not just somebody who's sending you data, but you got to be able to trust that thing. And you got to include that thing in the decision-making process itself. So first of all, you should be able to communicate your decisions to that thing. You should be able to work with that thing. And then you build this positive cycle where data is generated by a device or a gateway or a sensor and is sent to the cloud. Cloud analyzes it, and then you send some more further instructions, and then the device can do slightly different actions based on what you wanted to deep dive on. And then you get this positive cycle where you can actually automate a lot more processes than what we see in the world today. If we do that, I think we can then start transforming the businesses. So if you look at how does the transformation look like from the monetary sense, if you look at most of today's services, they look like this. I talk regularly with the customers, and most of them say, well, I want to do IoT because it saves cost, because it improves my efficiency, it removes some of the time delays. And you can see these examples, like if you are doing HVAC monitoring and adjusting the room temperature based on the occupancy and things like that, or turning down the lights when they are not required, obviously you'll have savings, no question about it. But if you just stay at that, you will get some benefits. There is clear ROI, I'm not denying that. But where I think we as an industry need to go to is this, where we transform the businesses. We don't just make them more efficient, but we create new business models. What do they look like? For example, instead of selling a thing as a product, you can actually help your customers selling thing as a service. For example, take printing. Take a printer. If there's a printer company, they sell printer as a product today. With IoT, you can actually sell printing as a service. Or instead of selling an elevator to a building manufacturer or a building manager, you can sell elevating as a service and then charge every time the elevator is used. So when you start thinking about these new services that you can enable, the potential of IoT is actually far bigger than what we as an industry are realizing today. How many of you kind of identify with that? Not a whole lot. So let me make it a little more concrete with an example. Here's a car. On a Monday morning, I'm driving to work, happy. Well, I shouldn't say happily. Monday morning work, not necessarily happily, but I'm driving to work, and something goes wrong with my car, and some warning light comes up, check engine light or maintenance required light or something of that sort. At that point, my car has detected that there is a problem. However, I have no idea what to do about that problem. At that point, I really don't know what to do. So after I say the things that my therapist warned me not to repeat on the stage, after that, I pick up my phone and call my dealer, right? That's what most of us do. And and I tried to schedule an appointment. At that point, my dealer has no idea why I'm calling, what's wrong with my car, or what they should do about it. So they just give me an appointment. I somehow take the car in for service. And you know the chain, right? I take the car in for service, they do the diagnosis, and then they say, oh my God, I need this part, but I don't have that part. Why don't you bring the car or leave the car for a couple of days? And it's just a frustrating experience for all of us, right? Part of the problem there is on the left-hand side. On the left-hand side, there is a phone or a browser, and a human like me is trying to interact with the back-end application. There's not so much problem with the applications. If you look at the applications like customer relationship management or resource planning, you do have those applications that have the workflows. It's just that one end is not the thing. It's a person. How can we change this with IoT? With today's IoT, we can actually do a little, but with tomorrow's IoT, when you start trusting the car as a first-class object in your enterprise application ecosystem, you can actually start interacting with the car. You can ask the car, some smart application in the back end can start talking with the car. And even before it shows me the light, it might have done some communication with the car where my car would have run some diagnostics and uploaded the data to the dealership or to the manufacturer of my car. And they would have told me already, well, looks like your car has a problem, but you can continue driving sometime in the next 1 week if you can come over to the dealership. And by the way, based on your schedule, here are a few appointments that are available near your home or near your work. Now I'm talking about something that's much better customer experience. The change that we have done is on the left-hand side, instead of the human, now we have the device and the IoT infrastructure that's making this change possible. But we don't have to stop there. We can go to the next level where you can actually do analytics on that. So instead of just basing the data decision based on what my car is reporting, there could be analytics running in the background that could say, well, all the cars in this geographical location that were the same make and model and the same number of miles driven had these kind of problems. That's what I have seen from a large number of vehicles. Hence, it is likely that you have this problem. Now you are talking about much better decision making than just one car and one incidence. Does that make sense? So when you think about the data, that at Oracle, we like to think about the two types of data. The first graph that's going down is the event-driven data. That's like something went wrong with my car. That needs to be acted on immediately, and the decision needs to be made very fast. The value of that data decreases over a period of time. When the check engine light came on in my car, I need to know about it, and I need to do something about it in the next 5 minutes because I have to make a decision. Should I pull over and call a tow company or continue driving? That incidence is not as interesting a week later, a month later, and certainly not a year or two later, right? So the value of that data decreases over a period of time. However, the same data, when it's collected from a large number of devices, the value, and now you see the other graph, the analytics driven, the value of that actually grows up exponentially because now you have the network effect. You have data from a large number of devices, and you can run analytics on it, and you can try, and you can actually come up with statistical models that actually predict what will happen to not only to your car, but also to the other cars that are out there. And that's where we get into the predictive maintenance, predictive analytics kind of space. And the value of that data, the cold data, but large big data, increases over a period of time. So what I submit to you is you have to look at the data both from the fast data perspective as well as from the big data perspective. The same incidence that my car had a problem, we got to harvest in multiple ways. There's no one single way to make it happen. Hopefully that convinced you. Now let's talk about how do we actually make it happen. Sounds all good. What's the practical way to create such a system? Obviously, such an ecosystem has three parts. You need the devices. As I said, you need to start trusting the car as a part of enterprise application ecosystem. You need a cloud service or an aggregator and a processor of that information that's collecting information from multiple things. And then you need the enterprise applications and integrate with multiple enterprise applications that will actually make the final decisions and create the revenue streams. Let's talk about the challenges. Most of the applications that exist today, take your customer relationship management, CRM, or enterprise resource planning, these applications are not going to go away even in the IoT world. They will have equal importance. However, they need to adapt. They need to adapt to a wide variety of data, much larger data, and frankly, more inputs or more analytics processed outputs coming into them, so then they can make better decisions. So these applications have a challenge. They need to stay relevant, but they also need to move to this new world. And some of these applications, some of the new applications will have to be created as well. When we talked about creating things as a service, you need a different kind of application. When you talk about remote patient monitoring, you need different kind of application that doesn't probably exist as much today. So we'll also have new vertical specific applications in addition to the applications that most enterprises run today. That's the application side problem. But if you leave that aside, on the device side, you have another problem, the bunch of devices. And here's where the scale becomes very important. There's so many of these devices, and they're out there. So security is paramount. We talked about making the device a first-class object in your enterprise ecosystem. You can't do that if you can't authenticate the device and trust that device. So security, identity management of the device, especially as it roams from a place to place, becomes a very important part of the problem as well. Most devices, they are always available, but they're not always on, as seen by the applications. Some of the devices are sleeping. Some of them lose connectivity periodically. Some of them only come online once in a day or once in a month. I worked in my past job on a pipeline monitoring project, and some of these devices come online once a week, and they communicate, and then they go back to sleep for another week. So many of these problems make enterprise applications job even more difficult, and IoT, to create a good IoT service based on cloud makes it more difficult. We talked about scale. There's a variety of format depending on the IoT vertical that you go to, from manufacturing to smart grid to healthcare to fleet management. You have transportation. You have various kinds of protocols. So we need, as an industry, a way to make them uniform and have common applications that we can build on top of this, a wide variety of devices. So how do we think about IoT at Oracle with all these problems? There are three main pillars to this. The first part is the acquire and manage. That's the part that talks about acquiring a lot of data from these devices. That means, but before I acquire, I got to be able to manage that device. I should be able to upload my software and some of my enterprise software onto these devices and authenticate them and things like that. And after that, I should be able to acquire the kind of data that I want to get from that device. Again, in today's system, most of the things, they send one stream of data. And for example, a thermometer would only send temperature reading. And that's about it. We need to get to more intelligent devices. And that's where some of the fog kind of work comes in as well, where we can actually delegate some of the actions closer to the edge. Or we can actually interrogate these devices to do more specific actions if I'm trying to drill down into one specific area for problem resolution. Once I acquire and manage these devices, then I get a lot of data. And that comes to the bottom part of this picture, where I need to analyze and act on that information. And act is important because we talked about the real-time nature of some of these events. In a manufacturing plant, if a boiler is showing that the pressure is close to a threshold, you can't just send that data to the big data system and run a batch job 3 hours later. And most of the times the boiler has blown up at that time, and a big data system will tell you why the boiler blew up. But if you act in real time, you can actually prevent that boiler from blowing up in the first place. And then you, of course, do the analytics to find out what were the conditions that caused the temperature to rise or pressure to rise in the first place, right? So analyze and act in real time becomes quite important. And once you have that, then you have more processed data, more analyzed data that you can then start integrating with your back-end applications. And that's where you integrate with your applications in a secure way. You have to, depending on the industry, you need to store the data for forensics or debugging purposes. So you do all of that. And that gives you the end-to-end, from devices to the enterprise applications, end-to-end system. Here's the architecture that we are creating at Oracle for making that happen. This is very similar to the picture I just showed you. It slightly goes into details. On the left-hand side, you see devices. And there are multiple types of devices. There's not going to be just one kind of device, right? There are going to be devices that are smart enough and communicate directly to the cloud. Those are good devices because they tend to be more intelligent and you can do more interesting stuff with it. There are also going to be devices that are very cost sensitive or battery power sensitive, and for various reasons, or some of them work with legacy protocols that are not even TCP/IP based. So for many of these devices, the best way to communicate is via gateway. So we have the gateway software where you can actually connect and upload a bunch of data, do the protocol transformation, and send that data to the cloud service. Once that data lands up in the cloud service, you need to do a few things. Clearly, as we talked earlier, we need to first make sure the data is coming from the right source that we trust. So you need to be able to do device identity management, security of that data communication, and things like that. The data gets into a data ingestion system where we analyze that data, process that data in the fast real time. And there you get into nuances on maintaining the ordering between multiple events from multiple devices. You get into how fast you can process, make sure no single event is dropped, making sure you process every event exactly once, and some of the events you can actually process multiple times. So you need to be able to be aware of what kind of processing you are doing and do the appropriate processing. Then you get into the event processing. And I talked about some of the fast data kind of applications here where you need to act on the data right away. So those analysis happens right there as soon as the data is ingested. There are other use cases where you need to detect patterns. You need to detect that the temperature is constantly increasing over 5 minutes. Only then you need to create an action. Sometimes many of these sensors also send a continuous stream of data that's actually not very interesting. For example, if you're looking at the pressure or temperature or a flow in a pipeline, I'm not very interested if the flow is 1,000 cubic feet per meter or 1,001 or 999.5. I'm only interested when it goes above 1,200 because my pipeline will burst, or if it goes below 700 because there's a leak. Right? So creating events out of the continuous data streams and doing data volume reduction, data deduplication becomes quite important use cases in those forms. And sometimes the event that you need to generate is when you don't have the data. So not everything is detected when there's a data. Sometimes a missing data itself is an event that somebody needs to do something about it. So all of that happens in the event processing. As I said, we need to also store this data into databases for forensics, for regulatory purpose. Depending on the industry vertical that you go into, you have different requirements on how much data to store. First of all, whether you can store or not, and for how long to store that data, and whether you need to encrypt it and anonymize that data before you store it. So we do all of that. And then finally, we can do event dispatching and integrate with the other platform as a service and the applications. So integration becomes very important, where you can take that data and then start triggering workflows. You need to maybe create a work order that needs 3 levels of approval before you do something. You need to maybe create a purchase order to purchase a replacement part. You need to maybe create a maintenance schedule to actually look at that problem in your next maintenance window. So all of that process gets triggered out of all of these events that we generate. And then after we have processed all that data, we have actually gained insights from these data. Then we hand it over to the enterprise applications like your CRM or ERP or process applications. And then the real decisions happen and the actions are taken. So that's kind of how we think about creating the use cases that I started my presentation with. With that, I would like to summarize. So IoT is all about, we started thinking as an industry of IoT being all about things, Internet of Things, that's what it's called. But I would like to submit to you, we got to start thinking about IoT as it's all about services and applications that we enable, because those are the outcomes our customers are looking for. So it's all about services that transform the data coming from all of these devices and things into gaining the insights and then make it into something that's actionable. So that's how, at least I personally like to think about IoT. The building blocks for IoT, obviously, we talked about the device cloud, where we have the devices, a processing layer in between, hopefully in the data center or in your cloud, that does the real-time processing and gaining insights work. And then the actual enterprise applications, where you monetize the entire solution. And obviously, when we launch our cloud service, we'll enable all of this. So with that, I thank you all. It's been a pleasure being here, and I hope you enjoyed this talk. Have a good conference.